Hey everyone, Mr. Kimsing here. Let's take a look at linear equations with brackets. Now, with linear equations, what's interesting is that there's a lot of different ways that we can approach the same kind of problem, right? And particularly with brackets, I also find this is true. And the way I want to put it to an analogy, it's kind of like a maze, right? If I have a maze here, there are a lot of different paths which get me to the same result, which is if I start in the middle of the maze and I want to get out to freedom, right? There's a lot of different ways I can do that. So what I can do is if I trace along here, let's see if I can get out of this maze. Ooh, looking pretty good. Ooh. Okay, I've got a bit of a fork here. Which one do I take? Up or down? Or left or right, depending on which way you're looking at. Let's try go up first, see what happens. Oh, it's looking good, looking good. I think we're good. Can't see anything wrong so far. Ooh. Let's go this way, and I think I am free. Alright, we're out. Woohoo! Alright, but the other thing you'll notice is if I had gone down or left, it actually links up the same way. It's actually a little bit quicker as well, right? So there's a lot of different ways you can get to the same result, but the thing I want to stress is that some ways can be easier for some people than others. And that's particularly true for linear equations with brackets, because when solving them, there are two main options, right? I think the first option is to expand. So anytime you see brackets, we've done the skill of expansions. So that's something you might want to do, right? The other thing is, if the numbers are given in a particular way and it works out, it may be simpler to divide by the value in front of the bracket. I'll give you an example of what I mean by that. Let me show you. So here I've got examples. So here I've got 4 outside of x plus 2 is equal to 4. And remember, to expand brackets, I'm going to do the first method. All right, to expand the brackets, so this is the expanding method. All right. So if I expand them, I multiply everything on the inside by the outside. Yeah. So I've got 4x plus 4 times 2, which is 8, is equal to 4. And I can solve this like the usual linear equations you've been solving. So let's take away 8 from both sides. That's negative 4. And then I divide both sides by 4, so I get x is equal to negative 1. And you can check that in your calculator as well. Right? So that's the first method. The other method, which is, let's call this the division method maybe, is what you can do is instead of starting off by expanding, what you can do is divide both sides by the number in the front of the bracket. So this number here, 4. If I divide both sides by 4, what do you notice happens? Well, I just get left with x plus 2 on this side when I divide by the 4, because that's multiplied and it's the opposite operation. If I divide the right hand side by 4, I just get left with 1. And you can see now I subtract 2 from both sides and I get x is equal to negative 1. So I get the same answer. But what it means is, I suppose in some sense, there's less algebraic thinking. All you have to do is divide and then subtract. Whereas this one you had to expand and then you had to rearrange as well. So the expansion can cause room for error for a lot of students. So that's just something to consider. Okay. Now, this only works in certain situations. So in the next one, it is going to work still. Let me show you. So if I use the expansion method, right? We've got expanding this out. We've got 3 times x, which is 3x, and then 3 times 4, which is 12, is equal to 18. And we can rearrange accordingly. We subtract 12 from both sides. And that gives me 3x is equal to 6. And we'll finish off by dividing both sides by 3. And that gives me x is equal to 2. Right? But when I use the division method, I get the same result. So I've got 3 outside of x plus 4 is equal to 18. And then I divide both sides by 3, so I get x plus 4 is equal to 6. And then I subtract 4 from both sides. So I get x is equal to 2. Okay, so same answer for this particular question. Where it becomes an issue is if this number here doesn't go nicely into the number on the right hand side in this particular form, then you end up with a little bit of a woozy. It's a fraction, right? So it's, do we really want to introduce fractions when we just had whole numbers? Probably not, right? So I would steer clear of using that method in a situation like this. It's just an option for you because I think mathematics is all about options, all the different things that you can do. So let's use the expansion method. So I'm going to expand. So multiply everything on the inside by the outside. So I get 2 times x, which is 2x, plus 2 times 1, which is 2. And so 2x is equal to 9. And it turns out the answer is a fraction anyway. X is equal to 9 on 2. Okay. Alright. Now let's have a look at this one. Same idea. I can't really use the division method here nicely. So what I'm going to do is I'm going to expand. So I get 6 minus 3x is equal to 7. We'll take away 6 from both sides because this here is a positive 6, right? So what I'm going to do is I'm going to be subtracting 6 from both sides to remove that positive 6. So I get minus 3x is equal to 1. And last but not least, this here means multiplication. So the opposite of multiplying is dividing. That's what I'm going to do. I'm going to divide both sides by negative 3. Okay? And so that's going to give me x is equal to 1 over negative 3. Or we can write that a few different ways as well, but that's one of the acceptable ways of doing it. Okay? Alright, last but not least, same idea here. I guess one thing that's confusing is they sometimes swap the variables around between the sides. So what you might notice is, oh, hang on, it's on the right hand side now. Does that change my process? Well, it shouldn't, right? Because all you're doing is just following the same procedures. We're expanding and then we're rearranging for the subject. Okay, so 13 is equal to 2 times 4 is 8. And then 2 times negative m is negative 2m. And then I can subtract 8 from both sides here, because that's a positive 8 here. I'll just write down the instructions. So I'm subtracting 8 from both sides. So I'm going to get 5 is equal to negative 2m. And again, m is going to be a fraction, but that's okay. We can use fractions in our answers. M is equal to 5 on negative 2 after I divided both sides by negative 2 there. Okay, so that's the idea behind the algebraic processes. We want to think about the opposite operations which are involved, and we want to ultimately get as our answer these letters equal to some number. And for all of them, you can still check if you put it back into the original question, is that going to work out? And they do for these ones here. Okay, so that's how we can look at linear equations with brackets, multiple different approaches. Pick the one that works for you.